Hello, everyone. My name is Jin Zhang. I'm the Senior Director of Product Management for VC Formal at Synopsys. Today, I'm speaking with Nilabja Chattopadhyay. Nilabja is a Design Verification Manager at Amazon Lab 126, where he leads the verification effort for several key subsystems, such as memory controller, neural accelerator, and multimedia pipeline. Nilabja is enthusiastic about deploying formal verification to where he can find more bugs in less time. Nilabja was a test bench architect before Amazon, working at Oracle, AMD, and Calvium. Nilabja has a master's degree in computer and electrical engineering from Cornell University and an MBA in corporate finance from Northeastern University. Welcome, Nilabja.
Hey, Jin, thank you so much for having me here.
Yeah, I first want to thank you for joining us in the North America VC Formal SIG event back in early October. A lot of people came to me after your speech and saying they were inspired by your talk. And that's why I want to invite you here today, because I wanted you to share your success story with all the design verification managers out there, facing the kind of challenges that you faced before and trying to find a solution to those challenges. So maybe we can start with you telling us a little bit about the verification challenges and why you went to formal as a potential solution for those challenges.
Sure. To set some background, my team specializes in simulation-based verification methodologies. Every now and then, we do get a verification challenge, which may be a little tough for simulation-based verification methodologies. One of those key examples are floating point 16 operation. We do have one of those in our designs, and the state space is 2 power 16 times 2 power 16, which is a really large number. To be able to get exhaustive coverage on that through constrained random simulation, it's going to take a really long time, and there is no proof that you've covered all possible combinations just because of the large sample space. So that provides a key opportunity to deploy a new methodology. And what we did in this particular case was we deployed data path verification, which is C model to RTL equivalence. And we were able to get 100% convergence on all of the operations that were supported, which does include some complicated arithmetic-based operations such as square roots and floating point, square roots and multiplication. We also deployed formal property verification in certain common modules such as Q-channel controllers. We've deployed sequential equivalence and clock gating changes just to verify that the design is equivalent with and without clock gating. And then we've also deployed formal register verification to ensure that our register generation tool, which necessarily may not have been siliconized, is perfectly okay. Now you can get 100% coverage there without running any simulations. So the UVM reg built-in sequencer, you don't necessarily have to run that. You can get 100% proof by just deploying FRV.
So, I have to congratulate your team for the courage that you have in diving deep into some of the hardcore formal verification problems, right, using data path validation tools. Because my understanding is that, as you said, your team come from a simulation background. They don't really have a lot of formal expertise, right, before taking on those, critical, important, but also difficult tasks.
That's right. So, when we got started, we had zero hands-on formal expertise within the team. We did attend special interest group for VC Formal last year, where the team just went in and absorbed all of the content, understood the levers and the powers that were available, and then we went back. And when we saw these verification challenges show up, we decided to take a stab. Now, because we didn't have necessarily the right technical expertise, this was not plan of record. It was more of a side initiative, and we went on the approach that if it's going to give us the right bugs, if it's going to give us the exhaustive coverage, necessary for sign off, then it could become plan of record. And in some of these cases, it did become plan of record. So it was an investment that we did because we weren't sure if it's going to succeed. And as and when it was going, we did find that when we were getting stuck, and this was in the case of verifying the floating point 16 implementation, we got stuck. We collaborated with Synopsys application engineers, and we were able to deploy some techniques to facilitate convergence.
So what kind of result that you've seen with the effort that you team? I mean, you talk about that's an investment, but what's the return of that investment?
If we were to talk particularly about verifying floating point 16, we spent about 8 weeks and we got about 10 plus bugs. Some of those bugs were in the RTL and some of those bugs were in the C model. And we also ran simulations in tandem, and the simulation-based tests were not able to expose this bug. Now, once you know that there is a bug, you can absolutely tune your simulation to expose it. But once you don't know that there is a bug, it's not the case, right? So we got 100% convergence. Again, we did have to collaborate with the application engineers from Synopsys on some of the complicated operations such as square root and multiplication. But we were able to get 100% closure. Now, when we deployed floating point, when we deployed FPV, floating point verification, we put it on a block with an interrupt controller, and we were able to get a bug within a couple of days while we were running simulations for about a month. So it was very powerful in catching corner case issues.
That is amazing. And as you said, you want to optimize formal for bug finding was time spent, and it seemed like
absolutely
you got there, right?
100%.
So just, looking back, if you were to summarize some of the success factors so that, other people in your shoes, like where you were back a year ago, if you can point them a direction to go, what would your suggestions or advices be?
Yeah, so my first suggestion would be that when we think about formal verification, from the community that does not have formal verification expertise, the ramp associated with it seems to be pretty high. There's a lot of industry notion that you have to have mathematical PhDs to be able to get results. From my perspective, while deep knowledge is absolutely desired, it may not be necessary for most of the challenges that are out there. And the reason for that is the EDA vendors have a lot of in-house expertise, and as they collaborate with their customers, diverse customers, that expertise gets built. So when you have a problem, and mostly what you'll get into is convergence issues, you can collaborate with the application engineers and then get the right feedback. The tool is evolving very rapidly. The techniques have been there, but that once you get stuck, it's pretty easy to be unstuck in most cases, right? Again, every now and then there will be a problem where you need that deep expertise, which is fine. And this is an investment where you're able to build that expertise, right?
So it sounds like what you're saying is don't be afraid to take on formal, even though it could be difficult, but the investment is worth it. And also with the support that your vendors can provide, you can solve those hard problems and really see value and left shift, right? Your
absolutely
cycle.
Absolutely. And the other key part is when you create a formal test bench, a lot of the collateral that gets developed is portable to simulation-based environments. Like in the case of floating point 16, we spent about 8 weeks, out of which 4 weeks was for infrastructure development. And a lot of what we did was portable right away. When you do formal property verification, you're writing constraints, you're writing cover properties, you're writing assertions. And I would argue that that's either way is necessary in a simulation-based environment, right? So you're getting double the mileage, and it's not necessarily investment or effort that goes down the drain, right? Because at the end, if you are getting exhaustive coverage, there's nothing better than that, right? You're getting 100% mathematical proof.
Yeah, absolutely. I'm so glad our SIG event last year inspired your team to take on this journey. I'm sure your message today will also inspire a lot of DB managers to seriously looking at formal and adopting formal. And we're both passionate about formal verification. I can't wait to see every company leverage formal verification to left shift their verification cycle. So thank you so much, Nilabja, for sharing your success story.
Yeah, thank you so much for having me.
And for our audience out there, if you want to know more information about VC Formal, please go to synopsys.com/VC Formal. Thank you very much, and we'll see you next time.